Hello again. So we are going to start on the properties of parallelograms today. So the definition of a parallelogram is a quadrilateral is a parallelogram if and only if two pair of opposite sides are parallel. Now remember that phrase, if and only if, means that the logic works in both directions. So if you know it's a parallelogram, then you're going to have two pair of opposite sides parallel. If you have two pair of opposite sides parallel, then you also know it's a parallelogram. The notation for parallelogram looks like a parallelogram. So you would say, for example, if this was a parallelogram, you would say parallelogram symbol A, B, C, D. Now, it only stands for a parallelogram. So no matter how bad your drawing is, if it's a four-sided shape, that means parallelogram and only parallelogram. There is no shape or symbol for a square or a rectangle or a kite or anything else, only for a parallelogram. Okay, some vocabulary, opposite angles. It's pretty straightforward. Opposite angles, so angle D and angle B are a pair of opposite angles. Angle A and angle C are a pair of opposite angles. Opposite sides, again, should be fairly obvious. AB and CD are opposite sides. AD and BC are opposite sides. Consecutive angles. So consecutive means one right after the other. And it's synonymous with saying they're same side interior. Because remember, if this is a parallelogram, then for example, angle D and angle C would be same side interior. Those are also considered consecutive angles. So you'd have angle D and angle C and angle B, also same side interior, angle B and angle A, and then lastly angle A and angle D. So as you could probably surmise, same side interior angles are supplementary, so consecutive angles in a parallelogram, they are going to be supplementary. Okay, so next. So we have three theorems to build on those, the definition. If a quadrilateral is a parallelogram, then both pair of opposite, and abbreviate a little bit, sides are congruent. So if we know this is a parallelogram, then you know that you can mark opposite sides congruent. If quadrilateral is a parallelogram, then you can also say both pair of opposite angles are congruent. So again, if I know this is a parallelogram, then I can mark the opposite angles congruent. Last one, if a quadrilateral is a parallelogram, then diagonals bisect each other. Okay, so that one is a little more involved of a picture. But again, if I'm given this is a parallelogram, and I draw in my diagonals, if they bisect each other, you know this intersection point here is a midpoint of both diagonals. And then you can also mark that these two smaller segments here are congruent and these two smaller segments here are congruent. Okay, using those properties. So again, you need to make sure that you know the shape is a parallelogram before you use any of those properties. But obviously, these should be fairly straightforward. So I will give you a second to pause and write two equations here and two equations here. Okay, welcome back. So you should have x squared minus 10 is equal to 3x. That's easy enough. And then you should also have y squared is equal to 36. On this side, you should have 4x And I separated those because this is only x's and this is only y, so you can solve them separately. But over here, you should have 4x is equal to 60 minus 2y. This is going to have to be a system with an x and a y. And then the other one is negative 10y is equal to 120 minus x. So here is my system of equations. Okay, so again, pause and solve both of these. Okay, welcome back. I'm not going to go through the gory details here, but you should get x equals 5 or negative 2. However, when you plug back into the picture, you need to double check that both work. When I plug in the 5, I get 15 here, and here I get, excuse me, 25 minus 10, which is also 15, so that one works. If I plug in the negative 2, I get a negative 6 length, so that does not make sense. Okay, so only x equals 5. Y, so if you square root both sides, you get 6 and a negative 6. When I plug in the 6 here, I get 36. When I plug in the negative 6 times negative 6, also 36. So in this case, both the positive and the negative work. So you do need to check for negative answers working in the picture. Okay, the system, so you're going to want to reorganize that first and then do eliminations, probably the easiest. But you should get y is equal to negative 10 and x is equal to 20. And again, I would always double check that those make sense in the picture. So here I get 80 degrees, and here's 60 minus 2 times the negative 10. It's minus a negative, so you're adding the 20, so that's 80 degrees. And then negative 10 times the negative 10 is 100, so that looks good, and that looks good. And then 120 minus that is 100. So this all seems to make sense. If you had trouble solving, you really should come to advisory so I can help you. Okay, so we are going to go through some basic proofs for these theorems. For the most part, obviously, we are skipping proofs, but it is always good to get exposure to the logic behind all of this math. So the first proof we're going to do is if a quadrilateral is a parallelogram, then opposite sides are congruent. So the given is always the if. So if I have a parallelogram, and then I'm proving opposite sides are congruent, so AB is congruent to DC, and AD is congruent to BC. So what I'm going to do is mark the picture with what I'm given. So what I'm given is parallels here and parallels here. Okay, and then this is a formal proof right here. That type of thing we are going to skip, but I just want you to be exposed to it. So given a parallelogram, my direct next conclusion is that I know I have parallel sides. You can't just assume that, you have to use the definition of a parallelogram. Okay, but now that I have parallels, I can mark some angles congruent. So here I see there's a Z right here, so I'm going to mark this angle congruent to that angle, and then I have a sideways Z going this direction, so this angle is congruent to that angle. So that's the start of this. So DAC, is this guy congruent to BCA. That looks good. Now we just need to do the other pair. So angle BAC is congruent to angle DCA. Now the reason we can do that is because we have parallels, I know that alternate interior angles are congruent. So that would be my reason. Okay, next, AC is congruent to AC. I'll mark that in the picture. And the informal way to say that is just a shared side. And then what do you know? We have congruent triangles by angle, side, angle. And then we can prove that corresponding sides of these triangles would have to be congruent. So that's where we get that proof statement. AB is congruent to DC and AD is congruent to BC. So that's an example of a formal proof for a theorem. Now you can prove opposite angles are congruent using pretty much the same logic, just a different CP/CTC. So I'm not going to go through that. But lastly, if a quadrilateral is a parallelogram, then the diagonals bisect each other. So this one I'm just going to talk you through. So the main point here is parallelogram, actually all of the quadrilateral theorems that we're going to do are really based on congruent triangles. So this format right here is super important for all of these proofs. So let me highlight, if I'm doing diagonals bisect each other, I'm really going to just isolate one of these little triangles. And we're going to figure out why that green triangle is congruent to this other guy over here. And then using CP/CTC, we can get these segments congruent. Okay, so we're going to go through marking the picture again. So I'm given a parallelogram, so I know I have parallel sides. And with that, I can mark, again, alternate interior angles. So I'm going to do this sideways Z right here. So I know this angle is congruent to that angle. And then I'm going to do the Z going sort of the other direction this way. So I know this angle is congruent to this angle. Okay, and then here's a cool thing. Now that we proved opposite sides are congruent, we can actually use that in a proof. So I am going to use that to help me. It'll make things a little shorter. So I'm going to mark that this side is congruent to that side because of that other theorem we proved above. Okay, so then obviously, hopefully, it's angle, side, angle. Same over here, angle, side, angle. Okay, so I'm just gonna sort of briefly put that in here. That angle, side, angle will get me the triangle. Let's go with AED, congruent to, so AED would go with CEB. And the reason would be angle, side, angle. From there, like we've done many times, we're going to use CPCTC. Now, you just have to think about which parts you need. So if I need the diagonals to bisect each other, like we talked about when I did the property, ED would have to be congruent to EB. Well, those are, so ED and EB are corresponding parts. So ED congruent to EB. I also need EA and EC, so EA and EC are corresponding parts as well. EC. Okay, and then once I get those small segments congruent, then there's some technical vocabulary you need to use. You would then define E as a midpoint, and then you would talk about AC and BD bisect each other. Okay, but this would be the basic logic of how to prove that diagonals bisect each other. I know some of you asked me about the pre-boxes. So the pre-boxes, I would concentrate on getting the triangles congruent for any type of parallelogram quadrilateral theorem. But the pre-boxes basically take you from the given to this angle, side, angle. So what you would start with here is parallelogram ABCD. Okay, and then that would give me the opposite sides. But from there, you would also need to know that you have opposite sides parallel. And then that would give you the alternate interior angles. So this is just some sort of, some logic that goes before figuring out all the parts for the triangles. Okay, so this is actually pretty complicated proof, but this is the basic logic of how that works. We'll see you next time.